In the previous videos, I showed you how to build a scatter plot and how to calculate a correlation coefficient. In this video, I'll demonstrate how to test the significance of the correlation coefficient. We will be building from the same example used in the previous video. Just as a reminder, here's the scatter plot for our example, where we plotted the pairs of values for the number of absences in the final grade. We wish to see if there's a significant relationship between the two. Of course, you will not be surprised to hear that we will keep with the usual 7 steps for hypothesis testing. So step 1, as usual, is identifying the test and stating why this test was chosen. In this specific case, we have 2 quantitative variables, which are number of absences and final grade. Furthermore, we're looking to see if there is a relationship between the two, so we will perform a R coefficient correlation test. Step 2, stating the hypotheses. In the case of the R coefficient correlation test, we always perform a two-tailed test, which means that the hypotheses are relatively simple. Recall that an R value of 0 indicates that there is no relationship between the two variables, so this will be our null hypothesis. The alternative hypothesis states the opposite, so R is not equal to 0. Step 3 is of course to state the level of significance. For example, we will state that it is 0.05. We can now move on to step 4, finding our critical value. Here's the table we will use to find it. First, we must get our degree of freedom, which in the case of correlation is n-2, so 5 because we had 7 pairs of values. Then we recall our level of significance, which was 0.05. In the table, we simply find in the top row our level of significance and in the first column our degree of freedom, which will give us our absolute critical value. Recall that we have a two-tailed test, so we have 2 critical values, which are positive and negative 0.754. Of course, for step 4, we also have to sketch it. Now with this test, there's no distribution to draw. Rather, you will use the scale as presented here. Our critical areas are shaded in orange, and we indicate whether our critical values are as so. Next step is to calculate the R value for a distribution of values. Here's a reminder of the equation and of the final values. Recall that we have calculated an R value of minus 0.944. If you're unsure of how we got that value, please return to the previous video. Now we verify if we reject or not the null hypothesis. Let's bring back the scale to give us a visual aid. Our calculated value was of minus 0.944, which falls approximately here on the scale. We must state, because our calculated value is lower than our critical value, and as such falls within the critical region, we must reject H0. So we're now ready to summarize the results, the final step. There is a significant relationship between the number of classes missed and the final grade. Indeed, it appears that the higher the number of classes missed, the lower the final grade. And now, of course, it's your turn. Pause the video and find if there is a significant relationship between these two variables at a 0.1 level of significance. Don't forget to do your scatter plot. Now you should have a calculated value of 0.897, which, when compared with the critical value, indicates that there is no significant relationship between the two variables.